So I'll share my screen and we'll see what we are going to do today in lab first. Okay, so today we are going to see how we are going to pre-process this raw text data. That is basically the text. So I'll give you choice, like you can either download data from any online repositories, you can work with it, or you can import some inbuilt corpuses in the NLTK. If you have read that in the last assignment, so there are inbuilt data sets in natural language processing toolkit. You can use those data set to pre-process this. So you can work with it. So I will also share a link how you can do that. Okay. So let's start. So here, first of all, uh, okay, tokenization, capitalization. We all know this. Normalization. Just have a quick review of steps that we are going to that you are going to do in lab as well as for your theory purposes. So first thing is, so suppose we have a raw text data set, which is a maybe set of sentences. So this is your first sentence, second sentence, third sentence, and you want to classify it as output as a positive sentence, negative sentence, positive sentence. So classes are positive and negative. So just example of simple sentiment analysis. So we have seen that we know that there are several steps that we need to follow. First of all, we need to tokenize it, right? Then we need to change the case of all the words in the sentence to lowercase. Then we need to do stemming and limitization, right? This is also called normalization, stemming and limitization, right? So we have discussed this in theory. So today you are going to do this in practical. And suppose this is word 1, word 2, and so on. Similarly, word 3, 4, and so on. Okay, so these are the set of words that you were having. So after you tokenize it, so in tokenization, you will get separate words out of this. So suppose sentence was hello, how are you? You will get set of words as hello, right? How are you? Now this depends upon which tokenizer you are using. So types of tokenizer plays a premium role in dividing your sentence. So you need to check which tokenizer you want to use. So there is tokenization for punctuation. So if you are using a sentence like hello, comma, how are you, question mark. So punctuation tokenizer will remove all the punctuation marks and it will only give you output as set of words. Okay. Suppose you are using tweet tokenizer. Okay, so sentence was suppose hey, and then I put a smiley and what's up. Okay, so tweet tokenizer will separate this out as hey, then this is another, I will use another pen, so it's hey, smiley is another token. So if you are using punctuation tokenizer, the smiley will be removed because this is colon. According to punctuation tokenizer, this is colon, this is hyphen, and this is bracket. Okay, so this will be removed. While if you are using tweet tokenizer, it will be separated out. So smiley is there. This is second token. Third token is what's. and fourth token is up, right? So depends upon what kind of tokenizer you are using. Okay. Similarly, we have third tokenizer is white space tokenizer, which only removes the extra spaces, white space tokenizer. So what does it do? So there are many spaces in between. So such kind of things it will remove. Okay, it will not remove punctuation marks again. Okay, so depending upon what kind of tokenizer you are using, you'll get your set of words as output. So whenever you are processing any data set, you have to check what kind of data set it is. If it's a casual text data set like tweet or something, then you have to use tweet tokenizer and so on. Okay, so for today, you have to run this white space, word punk, and tree bank word tokenizer. I will show you example. Okay, over here. So NLTK dot word tokenize. So this is simple one. Let's move on to example where we have used. Okay, word punk tokenizer. So example here is, so there is backslash n and backslash n in the sentence. Okay, so from nltk.tokenize we have imported word punk tokenizer. Okay, so if I tokenize this sentence s using this word punk, so it will separate it out as this. Okay, so output would be good muffins cost. So backslash n's are removed, punctuation marks, etc. is removed, right? Another is white space. So here, uh, this is space in the sentence. This hello space is removed. So the sentence was ABC is equals to hello space house space backslash n is next line character r tab character space u. And if you print this sentence, you will get something like this. There is a space and there is tab and there is next line. Okay, it is automatically inbuilt. It is automatically taken in the sentence. Now, if you are tokenizing this, all these tab spaces, new line characters, etc. are removed. Okay, so depending on which tokenizer you are using, it will give you as output. After this, after this tokenization, you have to change your text to lowercase. So whatever corpus you are downloading, first of all, so this because why do we do this? Otherwise, if you don't convert this to lowercase, it would be hello is a different word and hello is a different word. So to consider these two as same, so we change everything to lowercase. Okay. Then we have stemming and lemmatization. So here in the assignment, you can use this potter stemmer, okay, and wordnet lematizer. So these two are already there. If you visit this nltk, and you have to just pick an example and execute this. Okay, so you know the difference between stemmer and lemmatization, stemming and lemmatization. So I'm not getting into details of this. So next is, so bag of words and term frequency and IDF. So these three are new to you. So I'm going to cover this one. Okay. So let's see. So first is bag of words, term frequency and inverse document frequency. So in bag of words, there is, suppose we have a sentence. Now, basically, why we are doing this? Question number one. First is why, what is the need of term frequency, IDF, what we are doing. So after you have done that, after you have uh, extracted the set of words from the sentence or the corpus means set of sentences, means the data set. Okay, corpus, data set, everything is dataset is one and the same thing. If I'm talking about sentence, so it is same as document, one and the same thing. Basically not one sentence, it is just one training example. So one sentence, so here you are having one sentence as one training example, so that's why we say okay, one sentence. So if I'm talking about document, so it is same as sentence. If I'm talking about corpus, it is same as dataset. Dataset consisting of all the training examples and their class labels. Okay. So so what, why this is needed? So after, so step one was we have done pre-processing. So in pre-processing, we had data set with set of sentences. So this was first sentence, second sentence, third sentence. What we have done was we have extracted set of words. Word 1, word 2, word 3, word 4. Okay. So step 2 is, so after we have extracted words from this, we need to convert this into vector form, right, to get into training model, training the model. Okay. Giving as input to the model. So step 2 would be feature extraction. So in class we have seen that there are methods like, we know one hot encoding is there. We know that we can count the number of positive and negative words, and then we can give that as input to the model. Okay. So here today third approach is so I will tell you what is bag of words so you can relate to this what is feature extraction. So let's discuss about bag of words. It is a very popular approach of converting the words into vectors so that those vectors can be given as input to the model. Okay. So in bag of words, what do we do is, it's nothing, just we have set of words like, okay, we have a training example. This is a fruit. So bag of word, TF, IDF, these all are frequency based. This is a fruit, name apple. Okay. And another example is apple is a really good place to work. Okay. So let's see. So these three are frequency based approaches. Frequency based because we are just counting the number of occurrence of each word in a sentence. Okay, so bag of words is nothing. We just count in sentence one how many times this is appearing. So we have discussed this in class, like we have vocabulary and vocabulary, and in vocabulary we have set of words like we have all these words in the vocabulary, including this. So after you have converted it into set of words, it will give you this, and is and a would be removed, so you will get fruit, you will get maybe named apple, then again apple, and then is a would be removed as stop word. One thing was missed over here. You have to do stop word also. Stop word removal should also be there after before this stemming and limitization. You should do stop word removal, right? Then apple, then really might be removed. So good place and work. So this would be generated, right? So these are the words that you are having. So in vocabulary, you would be having first word would be fruit. Fruit. Second word would be named, maybe apple. So this is your vocabulary, right? So for if you want to represent this fruit, you would represent it this as one, and rest all would be zeros, right? If you want to represent this named, so this would be 0, rest all would be, this is 1 only where this named was present, and rest all would be 0. Then similarly for apple, 001, 000, and so on, like this. Okay, so this is also called one hot encoding. So one example of bag of words is one hot encoding, where you are just counting the presence or absence of that word. Now because you can see apple is coming twice, okay, so its frequency should be more than one, right? So there is another approach. So in a bag of word model, there are two types of approaches. First is of binary, where you just say absence or presence of a word as 0 or 1, and another is frequency, where you frequency or maybe weights, where you count the number of words that are present in the total corpus, so everywhere. Okay, so you will count that and you will say, okay, apple is present 2 times, so you will, so vector, its vector would be having 002, 0000, and so on, like this. Okay, so bag of words is of two types. First is binary and second is frequency count, where you have where you will write that, okay, fruit was present 1 time, so I will write 1, and rest all would be zeros. And in apple, where apple was present, so because it was present twice, so I will write 2 instead of 1. Okay, so this is just a representation where you, so after doing this, what you have done is you have just extracted the features, right? You have just created a feature set, maybe something like this, where you have set of words. So you have extracted 1 2 3 4 5 6, 6 words were there. So feature 1 2 3, feature 4, feature 5, 5 6. So these 6 features are generated with values 0 1 0 0 0 0 0 0 2 0 0 0 maybe, okay, whatever. So something like this. So this is a matrix. Now you have a feature, now you have extracted features for giving as input to the model. Okay, so bag of words is just one approach. Another approach we have seen in the class, like where we just count the presence of positive and negative words, and we give input as x number of positive words, number of negative words, and 1 as input to the model. So in this approach, what happened was so much information was lost. While in this so this approach was better, but the problem with this approach was sparse matrix, right? So because we don't want a model to be trained on so many zeros, right? So this would definitely there's no use of it, and this would also increase the training time and all. Okay, we don't want this. So bag of word approach we generally avoid. So next approach is, so to, there is one more disadvantage of, so disadvantage if I write, advantage was, so first was sparse matrix, second was context of the word is not retained. For example, if you see this apple and this apple is different, so this apple is a fruit and this apple is a company, right? So there is a difference between this apple and this apple. Apple is a really good place to work, and this is a fruit named apple. So this is a fruit, this apple is fruit, and this apple is company. So there is a difference in the word meaning of that word, right? So bag of word is not able to differentiate. It will count apple as two. It will not differentiate like this is a talking about company and this is talking about fruit. Okay, so this is disadvantage. There is no semantic meaning of the word that is retained. Okay, second thing is it should also give weights to, like, which is the most important word in a sentence. So if suppose I'm talking about a cat, so I'm writing a paragraph on a cat. So cat is of this color, her eyes is of this color, cat is like this, cat is like this, cat eats this. Okay, so I'm talking about cat so much. So that word should, so that paragraph should give more weightage to a cat because I'm talking about cat in that paragraph, right? So this thing is also not done, not retained by this bag of word model. So for to remove this, we switch to TF-IDF. Now let's see what TF-IDF is. TF-IDF approach. So this is also a frequency-based approach. Frequency-based means, so whenever I'm saying frequency-based approach, I'm counting the presence of number of words in the sentence. Okay. So in all the frequency-based approaches, we just count the number of words in the sentence, presence of number of words in the sentence or maybe the document, which is a set of sentences. Okay. So let's see. So first of all, we have to see the formula for this. So let me, okay. So term frequency, TF is the term frequency is equals to number of repetitions of words in a sentence divided by number of words in a sentence. Okay, and IDF is inverse document frequency. Okay, so which is equals to log of number of sentences by number of sentences containing words. Okay, so in when I'm talking about term frequency, this means number of words. So this is basically the formula. Now, first of all, what we are trying to do here is we want to count the number of basically frequency of a word in a sentence, and we want to, because we are dividing it with the number of number of words in a sentence, so we are just giving weights. Basically it's just a weighted approach that okay, this word is more important because it is occurring more number of times. So if I'm talking about cat 5 times in a paragraph or something like that, okay, so if cat is, that means cat is more important and it should be given more weightage. So this approach is basically to give weights to the numbers, to the values of words where its presence matters. Okay, so let's see how this, and finally ultimately what do we do is we multiply these two and whatever we get is the final output. So first of all we calculate the presence of words in the sentence, and second thing what we do is we calculate the inverse document frequency, which means the presence of uh, uh, you know uh, presence of that word across the documents, presence of importance of those words across all the documents. Okay, so this is for particular one sentence, this is for one sentence or one document, and this is for the whole set of corpus. Okay, the whole corpus. Okay, so we actually want to find out the importance of the word in the whole data set, right? So let's see how this is done. So let's see an example. He is a good boy. First sentence. Second sentence is she is a good girl. And third sentence is boy and girl are good. Okay, so if I do all the pre-processing including tokenization, stop word removal, then normalization, stemming and lemmatization, and changing case to lower. So all the pre-processing is done. After I do all the pre-processing, I will get a set of words like good, girl, boy, and that's all. He, she, is, and, or, these are removed. So only 3 words I'll get, right? So after this, so first of all, I have to calculate the term frequency matrix, right? So term frequency matrix would be, so term frequency is basically finding the words in a sentence. So good, boy, and girl. 3 words are there. Okay, so I will calculate the frequency or presence of each word in the sentence. So in sentence 1, so this is first sentence, second sentence, third sentence. So in first sentence, so good appears 1 time out of total number of words. So total number of words were good and boy out of 2, right? So total number of words in the sentence and number of repetition of words in the sentence. So good is appearing 1 time in the sentence and total number of words were good and boy. So 1 by 2, right? In second sentence, good is appearing 1 time and number of words are good and girl. So 1 by 2. Again, for third sentence, boy, girl and good. 3 words are there and good was appearing 1 time. So 1 by 3, right? Similarly, for boy, it would be 1 by 2. In second sentence, it would be, there is no boy appearing in the second sentence, so 0. And in second sentence, this in third sentence, boy is appearing once and the words are boy, girl and good, so 1 by 3, right? Similarly 0, 1 by 2 and 1 by 3. So this is clear. Similarly, we calculate IDF. So we have generated matrix for term frequency. We'll generate matrix for IDF as well. So words are, again, we have 3 words: good, boy, girl, right? And we want to know its presence across the corpus. So IDF. So IDF is calculated as log of number of sentences. So log of 3 divided by. So log of 3 is constant because we have 3 sentences, right? Number of sentences containing words. So number of sentences containing words means how many sentences contain this word good. Okay, so good is present in all the 3 sentences, right? So 3 by 3. Then boy is present in first and third sentence. Okay, so 3 by 2. Then girl is present in second and third sentence, so 3 by 2. So this is total. So we have calculated TF, we have calculated IDF. Now the final step for this is we just want to calculate the final weights, or we just want to know what is the presence of uh, a word in the whole corpus. So we will just calculate it. Sentence 1, sentence 2, sentence 3, 3 sentences are there, and we have features like good, boy and girl. So we multiply TF cross IDF to get the final feature vector. Okay, so this is whole final output. So basically this matrix, whatever I'll get here, is the final output. So let's see. So here what we have to do is we have to multiply this good for first sentence with this good. Okay, so for first sentence we have 1 by 2 value over here. So we multiply this to get this first row over here. We will multiply this whole row This is equals to log 3 by 3 is 0. Okay, log 1 is 0. So we will multiply this whole good boy girl, this whole row, with the first sentence over here. So this would be 0 cross 1 by 2, right? So this 0 and this 1 by 2. Then we have again for boy, we would be having 3 by 2. 3 by 2 multiply by this 1 by 2, right? So log 1 by 2 log 3 by 2, right? Then again log 3 by 2 is multiplied by this 1 by 3. So 1 by 3, multiplied by 0 over here. Okay, so what we are doing is, so I'll highlight over here. So this whole good boy and girl is multiplied with this good boy and girl to get this first sentence, because this is whole we are talking about first sentence, right? Similar goes for second sentence. So we will multiply this and this with again this and this. So what we will get is, so for second sentence we will get 1 by 2 cross 0. So this is 0. Then we will be having 0 with 3 by 2. 0 cross log 3 by 2. Then we will be having 1 by 2 cross log 3 by 2. 3 by 2. Okay, similarly you will get 0 over here, 1 by 3 log 3 by 2 over here, and 1 by 3 log 3 by 2 over here. Now what does this whole matrix basically represent? What we are doing over here is, this is 0, this is 0. Okay, this is 0, this is 0, this is 0 again, and this is 0. So you can see in the first sentence the important word is boy, and that is what we are looking for. So boy, he is a good boy, because we are talking about boy. So boy is having some weight, some value. It would come out as 0.5, 0.4, something like that. So this value would be calculated as something, 0.2 maybe, anything. So we are just, so rest all entries are 0. So those entries are 0, this is also 0. So those entries are 0 which we don't want to give importance to. Okay, so important word is boy in first sentence, so boy is having some value. Important word is girl in second sentence, so girl is having some value. Important word is boy and girl in third sentence, so boy and girl both are having some weight, some value. Okay, so this is clear up till here. Any questions, anything?
No, ma'am.
No, ma'am. No questions? Easy, this is very easy. Okay, so I have just, what I have done here is, I have just imported few words, and then I have imported stop words from NLTK, if you have read that. So I have imported stop words, then I have removed those stop words. First of all, you have to take a sentence, okay, maybe a sample sentence, and then you have to tokenize it. Then you have to do stop word removal using given set of words in English. So stop word list in English, this is already built in, and you can use it as it is and remove the words which are not required. Then you will get set of words. So after you get set of words, what you have to do is you have to apply this bag of words, stemming and lemmatization as well. So this is just one line of code, you have already worked with it. So visit NLTK and you can apply Porter stemmer and WordNet lematizer, right? Then you have to extract features using bag of words. You have to print this term frequency matrix, and you have to print this inverse document frequency matrix. So this is your assignment for today. Okay.